So for example number 1, we have this circuit where R is equivalent to 500 ohms, where inductor is equivalent to 0.64 Henry, where capacitor is equivalent to 1 microfarad, and we have a current source I, which is equivalent to negative 1 ampere. The initial voltage drop across the capacitor is 40 volts. The initial inductor current is 0.5 ampere. To find IR of, IR of 0 plus, IC of 0 plus, DIL dt of 0 plus, S1 and S2, the expression IL of t for t greater than or equal to 0, and the expression V of t for t greater than or equal to 0. We have VO of 0 minus equivalent to 40 volts, just equivalent to VO of 0 plus. We are given the initial inductor current equal to 0.5 ampere, just equivalent to IL of 0 plus. So solve for IR of 0 plus and IC of 0 plus. So at t equals to 0 plus, we have this circuit. We have negative 1 ampere. We have capacitor. The charge of 40 volts. An inductor. An initial current of 0.5 ampere. We have a resistor. We have IC at 0 plus. We have IR of 0 plus. So IR of 0 plus is equivalent to 40 over R. So we have 40 over 500 is equal to 0.08 ampere. This for A. For B, we have IC of 0 plus just equivalent to, so if you apply KCL at the top node, IC of 0 plus is just equivalent to I is negative 1 minus IL of 0 plus minus IR of 0 plus is equal to negative 1.58 amperes. For C, we have find DIL dt of 0 plus. So the voltage across an inductor can be expressed as L DIL dt. So DIL dt at 0 plus is equal to VO 0 plus over L is equal to 62.5 amperes per second. Now for D, we have at t greater than 0, so the switch is open, so we have a current source in parallel with the RLC circuit. Solving for alpha, we have 1 over 2RC equivalent to 1000 rad per second. Our omega naught just equivalent to 1 over square root of LC equal to 1250 rad per second. Now since alpha less than omega naught, for S1 S2 for the roots is equivalent to negative 100 plus minus square root of 1250 squared minus 1000 squared equivalent to negative 1000, okay, plus minus j 750. We have answer for D. For E, we have expression for IL of T composed of a forced response plus the natural response. So for the forced response, treat the circuit as a steady state circuit. Of T approaches to infinity, we have current source in circuit. So the capacitor is an open circuit and the inductor is a short circuit. We have resistor. We have I, L, F. So we have the force response of IL. This is negative 1. Looking at the circuit, for IL of F, just equivalent to negative 1 ampere. For the natural response, since alpha is less than omega naught, so our circuit is underdamped. So the natural response is equal to AE to the negative 1000t cosine of 750t plus BE negative 1000t sine of 750t. Our complete response is IF plus IN. So we have AE to the negative 1000t cosine of 750t plus BE to negative 1000t sine of 750t minus 1. Solving for the coefficients A and B. So at t equals to 0, our IL of 0 for IL of 0 is equivalent to 0.5 equal to A. So e to the 0 is 1, cosine of 0 is 1. Then we have sine of 0 is 0 plus 0 minus 1, where A equal to 3 over 2. Now for getting the value of B, we need to integrate, or we need to derive this equation. DIL dt is equal to, now at t equal to 0, or DIL dt of 0 just equivalent to 62.5. Then plugging in the value of A, solving for B, we have 1000A as 750 B. We have B equal to 25 over 12. So our complete response for IL of T is equal to 3 over 2 e to the negative 1000t cosine of 750t plus 25 over 12 sine of 750t minus 1 u of t amperes. Now for letter F, solve for V of t. So V of t is equivalent to, so this can be expressed in terms of the voltage across the inductor is L DIL dt. Getting the derivative of this equation, IL of t is this equation right here, and plugging in the values of A and B, you will get the expression for V as 40 cosine 750t minus 1160 over 3 sine of 750t u of t volts.